So, a pleasant morning for each and everyone. So, to my dearest classmates and to Sir Zaragoza, I want to welcome you all for this presentation. So, before I start, I hope everyone is having a good day and yes, just sit back and relax. And I hope you'll be able to learn something like insights and knowledge for this particular topic. So, before I start, I'd like to quickly introduce myself first. So, I am Rosary May Defensor Montebon from the Group 1. So, on behalf of my group mates, welcome once again for this presentation. So, let's start now. So, our topic for today is all about nuclear chemistry and its contribution to sustainability. So, before we start the presentation, I want to give a little bit background about what is nuclear and nuclear chemistry. So, did you know that in nuclear science, the word nuclear means of or relating to or constituting the nucleus of an atom. So atoms are the fundamental constituents of everything around us, and we ourselves are entirely composed of them, which is the atoms. Yes. And then and when we say nuclear chemistry, it deals with nuclear reactions or reactions that happen inside the atoms. So in simple words, nuclear chemistry is the study of how atomic nuclei can change into new nuclei. So since I already told you a little bit background about the presentation, now let's go and know more about it.
What is nuclear chemistry? Since we all know what chemistry is, which is the study of matter and the changes it can undergo, now it might be less difficult for us to understand nuclear chemistry. Whenever we hear the word nuclear, the things that might come into our minds are bombs, explosions, or in general, danger. Well, we cannot say that it is irrelevant to nuclear chemistry. But actually, there is more to nuclear that will shock or astonish everyone. To continue with, nuclear chemistry deals with nuclear reactions or reactions that happen inside atoms. Nuclear chemistry is a subfield of chemistry dealing with radioactivity, nuclear processes, and transformations in the nuclei of atoms, such as nuclear transmutations and nuclear properties. So to make it precise and clear, nuclear chemistry is concerned with changes in the nucleus of elements. It simply deals with nuclear reactions or reactions that happen inside the atoms.
Importance of nuclear chemistry. Nuclear chemistry is the foundation for many valuable diagnostic and therapeutic approaches in medicine. It has tremendously aided in the knowledge of medical treatments and has allowed these treatments to improve. It entails the investigation of the generation and application of radioactive sources in a variety of processes. Nuclear chemistry has numerous applications in the field of pharmaceuticals, industry, medicine, research, and in our daily life. It is so beneficial that it has improved the quality of our lives. Radioactive elements are used for the diagnosis of various tools, and they are majorly used for the treatment of cancer. As a result, nuclear chemistry greatly assists the understanding of medical treatments, such as cancer radiotherapy, and has enabled these treatments to improve. It includes the study of the production and use of radioactive sources for a range of processes.
Now let us proceed to the applications of nuclear chemistry. First is the nuclear reactors. A nuclear reactor is a device in which nuclear reactions are generated and the chain reaction is controlled to release a large amount of steady heat, thereby producing energy. In the early era of nuclear reactors, during 1940s, a reactor was known as a nuclear pile or atomic pile. Nuclear reactors are used at nuclear power plants for electricity generation and in nuclear marine propulsion. Next is the nuclear waste. So a nuclear waste is a radioactive waste, meaning that it spontaneously emits radiation. It usually originates from the byproducts of nuclear reactions in applications such as medicine and research. A major environmental concern related to nuclear power is the creation of radioactive waste such as uranium mill tailings, spent or used reactor fuel, and other radioactive waste. These materials can remain radioactive and dangerous to human health for thousands of years. So, due to its harmful nature, there is strict government regulation on its safe disposal. A nuclear weapon. A nuclear weapon is commonly defined as a device which uses a nuclear reaction, either fission or a combination of fission and fusion reactions, for destructive means. There are two types of nuclear weapons: the atomic bomb and the hydrogen bomb. A nuclear weapon, also known as nuclear bomb, is an explosive device that derives its destructive force from nuclear reactions, producing a nuclear explosion. Weapons whose explosive output is exclusively from fission reactions are commonly referred to as atomic bombs, while weapons from fusion reactions are generally referred to as thermonuclear weapons, or more colloquially as hydrogen bombs. The Chernobyl disaster. The Chernobyl disaster was a nuclear accident that occurred at the Chernobyl nuclear power plant on April 26, 1986. It is considered the worst nuclear power plant disaster in history. The number 4 RBMK reactor at Chernobyl nuclear power plant in Ukraine went out of control during a test at low power, leading to an explosion and fire that demolished the reactor building and released large amounts of radiation into the atmosphere, which eventually spread all over Europe.
Radiation in biology and medicine. Radiation is a form of energy which travels from a source as waves or as energized particles. At the lower end of the radiation spectrum, we find radio waves and microwaves, which are generally considered harmless. In the field of medicine, the use of radiation is now pervasive and routine. From their crude beginnings 100 years ago, diagnostic radiology, nuclear medicine, and radiation therapy have all evolved into advanced techniques and are regarded as essential tools across all branches and specialties of medicine. So when it comes to radiation, the first thing that comes in our mind is that it tackles or focuses about heat or kind of heat waves. However, in the field of medicine, radiation is now used for treating different illnesses, especially cancer patients. There is a certain medical machine nowadays that uses radiation to shrink or even kill cancer cells para dili na mo spread ang cancer cells sa other parts of the body sa usa ka cancer patient. Next is positron emission tomography. Positron emission tomography is one of the beneficial real-life uses of nuclear chemistry. Simply, it is a handy instrument that physicians use to take images of an individual's body to determine if a person is at risk for a certain disease or carries one. So the positron emission tomography, or PET, it is a kind of medical machine that checks a person's body if there are some risks or diseases pa siyang gidala. It is more likely an X-ray machine since it also gives images or pictures of a person's internal body. So next is the radiocarbon dating. So radiocarbon dating is the process of determining the age of a sample by examining the amount of C14 or carbon-14 remaining against the known half-life 5,730 years. So radiocarbon, familiar na siya, no? So radiocarbon dating is used by archaeologists or scientists to determine the estimated age of a sample or organism. So radiocarbon dating is widely used on artifacts and suspected fossils of a certain species like the dinosaur. So how did the scientists or archaeologists estimate the age of an artifact or fossil? So the scientists or archaeologists just simply analyze the amount of carbon-14, a type of radioactive isotope of carbon that are most likely found in charcoal in bones. So the lower the percentage of carbon-14 in a certain bone, the higher its estimate age. Next is the Shroud of Turin. The Shroud of Turin is the linen wrapping cloth that appears to possess the image of Jesus Christ. Some people believe this to be the cloth that he was wrapped in following his crucifixion. So the Shroud of Turin daw is a cloth or linen cloth that has images of Jesus Christ. So and some people believe or said that This cloth or the shroud of Turin was used when Jesus Christ is suffering from punishments for katong crucifixion.
The contribution to sustainability of nuclear chemistry. The nuclear energy could help in mitigating the global climate change. It has a key role to play in decarbonizing the energy sector but also support the attainment of all sustainable development goals. And also nuclear energy is a key source to balance the 3S: energy security, economic efficiency, and environmental sustainability. So ang nuclear chemistry daghan gud siya application and contribution to sustainability that can be applied in pharmaceutical industry, medicine, research, and also in our daily lives, including the elimination of poverty, zero hunger, clean water, affordable energy, economic growth, and industrial innovation.
Thank you so much for that very informative presentation regarding nuclear chemistry and its contribution to sustainability. So to sum up everything, nuclear chemistry deals with nuclear reactions or reactions that happen inside atoms. And nuclear chemistry is the study of how atomic nuclei can change into new nuclei. The atom itself is changing in nuclear reactions. As with conventional chemical reactions, a nuclear reaction is accompanied by energy changes. The energies within the nuclei of atoms are hundreds of thousands of times larger than the energies of chemical bonds. In order to balance nuclear reactions, one must focus on the subatomic particles within the atom, which are protons, neutrons, and electrons. So that is what nuclear chemistry is about. As we present you the presentation regarding nuclear chemistry and its contribution to sustainability, I hope that you learned something about the topic. And we, my group, would like to thank you for listening and cooperating during the presentation. Hope that this presentation has given you a much clearer understanding of the topic. Once again, thank you.